Okay, now, uh, yesterday we have two of them, right? We have two of them. I'm not going to ask you the mid. If I ask you, I'm going to ask you only the left or the right. So how do we get to the left? Better one. Okay, maybe just a curve like this. There. Yesterday we want to find the area between A to B. Okay, we use the right endpoint. Okay, I want to make there. Okay, right endpoint. So what did I do? I'm gonna draw, let's say, four rectangle, right? Four rectangle. One, two, three, four. One, two, three, four rectangles. Okay, and each rectangle, I'm gonna pick the right end point. That means the right corner rectangle. Right corner of each rectangle lands on this curve. So if the first rectangle go up, right here, the right corner would be right here, right? The second one, the right corner would be right there. And third one, fourth one, there you go. That is right end point. So R4, I use R4. Okay, how about left end point? Maybe here. There, same curve. Okay, just recall, huh? Just recall. A, B, left. Okay, now each rectangle, I'm going to pick this point that lands on this curve. So the first one would be that. Right. Second one would be here. Third one would be there. Fourth one would be there. There, you see that? Okay. Then can you visualize the midpoint? Just an example. What do you think? Maybe four rectangle. So maybe visualize M4. What do you think? Midpoint with four rectangle. If I have to draw the midpoint, I'm not going to ask you to do the calculation if you have midpoint or upper or lower, but I may ask you just to visualize it to see if you understand. Okay. If we want to estimate using four rectangle, okay, how do I put those rectangle? Okay, where do I put them? Midpoint.
Like it's f of like the second rectangle, the x value of the second rectangle, because it's in the center.
No. You still have four rectangle. Okay. The difference is not the second one, not the middle one right here. That mid not mean the middle of A and B. Mid, that means the middle of this rectangle. So left is right here, right? Right is right there. Midpoint, not really midpoint. Midpoint is the point in the middle of that rectangle. Okay, in the middle of that rectangle. So let's say if I have four rectangles, let's say split it 1, 2, 3, 4. Okay, right there. Okay, better. There. Try. So the midpoint. Okay, if right, you're gonna from here, right? You go up, hit, draw a rectangle, right? Left, let's say you go here, up, right? Mid, you look for exactly the point in the middle, right there. You go up. That's where you start drawing the rectangle. Okay, so the midpoint right there, in the middle, in each interval, at the middle of each interval, you goes up. Right there, we're gonna draw the rectangle. There. Second one. There. Third one. And fourth one. There you go. See? See the picture? Right. Make sense? That was meant by picking the midpoint. Okay, how do we find this number if we were asked to find? How do we find this number? How do we find this number? Can we find it? Can we find it?
Like that's 4, you can do like 8 triangles, I guess, and then just calculate like the x at 1/8.
Yes. There you go. Around it. Okay. And if we do the yesterday, we also introduced this notation. Right. Oh, actually x4. Right. Okay. All right. So midpoint. Go up. Okay, 1, 2, 3, 4. Let's say 0 to 4. Okay, I give it 0 to 4. I have 4 rectangles in there. What would be the first value? The first point right here. What would be the number right there? 0.5, right? That is 1, this is 0.5, the second one, and so on. See, you get the number. So that's how you pick the midpoint. If you have to ask, okay, that is M4. If you are asked to do the right 4, the first one will be 1, right? You go up, 1, 2, 3, 4. Second one will be 2, 3, and 4. Okay, and so on. Okay, upper and lower. Upper and lower. I'm going to borrow this. A, B. One more time. 4 rectangle. Maybe not really there, there. Maybe there. Okay. 4 rectangle around there. But this time, how do I know where to stop the height of the rectangle? Okay, let's say the first rectangle. Let's say the first rectangle. Okay, upper, huh? Upper. This is upper. We're doing U4. Okay, L4 down there. Lower 4 down there. Okay. Go up, right? Upper. What does it mean? Mid, you pick the middle one. Left, you pick the left corner. Right, you pick the right corner. Upper, you pick the highest point. So in this rectangle, where is the highest point on the curve? That point right there, right? That point right there. That will be the first rectangle. Okay. For the second one, if I go up, look. Okay. So that's mean on this curve right here, from here to there. Upper. That means the highest point will be this one right here. Okay. Next one. If I go up, the highest point will be on the right. And lastly, this right there. Okay. Understand? Right. I think you can draw the lower. You can visualize the lower. Okay. For the lower, okay, just Okay, actually I'm going to draw it on top of this, the lower. The lower will be the purple one. Okay? So for the lower, first rectangle, where do I stop? Where do I stop? There, right there, right? Right there. Second one, same right there. Third one, right there. And the fourth one will be right there, right? You understand that? There. Also same over here. Same over here. Same over here. There. The purple one is the lower. Any question? Okay. But in terms of calculation, if I ask you to actually do the math, I will only ask for L4, L, the left and the right. And it could be different rectangles. Could be different number of rectangles. Could be 4 rectangle, 5 rectangle. Okay, 6. Okay, 10 is too much. 6 is maximum. 4 to 6 around there. Okay, you just have to draw, and then find the area each one of them. Add them up. You get the approximation. But I may ask you to draw upper and lower. Just that. Give you a curve. Can you visualize finding area using 6 rectangle? Can you do that? Okay. All right. Moving on. Okay, something like this. This is a very standard example. This is a big example. It's comprised of many small examples. So we're going to do exactly the same on both. Like the first example. Exactly like the first example. Okay. First example that we did yesterday was the parabola, remember? Parabola between 0 and 1. We cut it down into 4 rectangles, remember that one? Yeah, this time exactly the same. A different function. It's still a parabola right there. Still parabola. Still parabola. Between -1 and 3, using 4 rectangle, okay, with right hand point. That means looking for R4, right? R4. Looking for L4, looking for M4, and the last one I'm gonna do this one for you guys. Okay, last one I'm gonna do this one for you guys. Okay, so because this is the same like the first one, how about you try that? Try that. And in case you don't know what this one look like, what does this one look like? What does this one look like? A parabola. But where is actually the parabola? If I have to draw that. That plus 4, right? Shift up by 4 units. So 1, 2, 3, 4. There, around there. 4. Okay. -1. 2, 3. So 1, 2, 3. This one you may want to draw a little bit careful. Okay. Again. Okay. There. So the area right there. Okay, that one. Okay. That area. Now using the right 4 rectangle, right? With 4 rectangle, using the right endpoint, so draw 4 rectangle using the right corner, and then find R4. Okay, if the problem 6 rectangle, R6. Okay. So I help you with the rectangle first. Okay, rectangle. Right. So that means the first one will be this corner. That corner. Second one will be that corner. Third one would be this corner. Fourth one would be that corner. Okay, so you have 4 corners. What is the width of each rectangle? Just one. Yeah, it's just one. So delta x is 1. So okay. So now R4. We know that delta x will be in, okay, either you can put it here or here, right? So delta, okay, let's write that. Delta x, f of x1, f of something plus f of something else. Because there are 4 of them. So I have 4 something. Okay, that would be the length of each one of them. Delta x right there is 1, clearly. The first one, we usually go from left to right, right? The first one would be f of this one right here. 0, 1, 2, and 3. Right. 0, 1, 2, and the last one is 3. So 0, 1, 2, and 3. Okay. And delta x is 1. What would be f of 0? 4. F of 1? 7. F of 2? 16. F of 3? 31. 31. Okay. Where did we get those number? Right here? Plug in here. That's your f of x. 0 in here. Disappear. 4. 1. 4 plus 3. 7. And so on. Okay, that's how we get this number. That's the length multiplied by the width. Not really matter, right? 20, 38, 58. There you go. That's what I'm going to look for when you do this kind of problem. Right now we are approximating. That's very off from the, not really off, but the actual value. Let's see later, the last one, part D, A, B, C, D. The last one will be calculated true value of this one. And we're going to compare, okay? So right now, R4 is 58. Okay, we approximate around this area is around 58 something. Okay. This means the actual value of 4 plus 3x squared dx, that interval, right? That interval between 1 and negative 3 is around 58. Right. That is actually what happened yesterday. Everything we learned yesterday was this. We're approximating this. And this, no more, no less, it's just the area right here. Okay. Between 1, negative 1 and 3. Okay, last one we're going to actually calculate this using the formulas. Okay, left and point. Left and point. Let's try that one more time. I hope you're comfortable with the process now. So let's copy and paste just the plot. Just the plot. But this time do it one more time with left corner. Okay, L4. Okay, same interval in negative 1, 2, 3. Okay, but this time for rectangle, L4. L4. There, the previous one's still there. You can replicate that, but using L4. That one, what do you think about this one? Overestimate or underestimate? The R4. Over, right? A lot of leftover right there, over. So the true value we're about to compute is going to be smaller than this. Then if you draw this one, we should expect underestimate. Okay, so four of them, left, right there. Second one, that'll be 0, 1, 2. Okay, third one, fourth one. Okay, that's the left one. Okay, but this time our starting point and ending point different, huh? Okay, but the width of each rectangle will be the same, still 1, 1, 1, 1. Okay, so delta x is still 1. Okay, but this time, what would be the 4f? 4f of something, right? We have maybe a different one. Okay, so 1. First one will be this one, right? That will be f of -1. Second one, 0, 1, and 2. So you have -1, 0, 1, and 2. Okay. F of 0 is 4. Okay, we can also, when you do this problem, you can recycle the value f of 1 right here, 16. F1 is 16. No, 7. F1 is 7. F of 2 is 16. So 7, 16 here. And also you are calculus student, right? You don't plug in anymore. That function. Negative or positive value plug in, they always have the same, right? See the same height. Right? It's even function. It is parabola. The point on the left reflect over the point on the right. So f of -1 is f of 1. 7, 7 here, 7 here, 16. There you go. Okay. 20, 14. 34. Right, 34. Okay. Oh, they vary off if you look at closely. Because we only have, okay, why? Why is it so off? 4.
We're not taking f of 3.
You say that?
We're not taking f of the highest value.
That is one of the point. But that doesn't mean even if we take in the f of 3, that doesn't mean we're gonna have. It could be over-explained. Doesn't mean we have the correct approximation. Another reason.
There's an area that we're not calculating for in the curve on top of the rectangle.
This point, yeah. That is why you have the error between 34 and 58. And the actual value somewhere in the middle. The actual value somewhere in the middle. It's still very off between them. You up, remember last time we off a few decimals. That's critical. This time you off many units. This time this is around 34. But why? Why so off? We learned it yesterday. This concept. Because it's underestimate, yes. Underestimate, overestimate, yes. But why it's so far away? I'm just going to let you know the final answer is 44. This one, they actually equal 44. The true value. So the bond on the top of around 14 units. That's a lot of off, right? Down here, of 10 units from that. Very far away. You want around maybe 44, you want around 45, 43, okay, maybe 44.1, okay. But now it's 34. But they are true, they are correct. This is the correct answer for L4. 58 is also a correct answer for R4. But the nature of these two is just off from that a lot. Because,
We're not using enough triangles to get configured.
there you go. We only use 4 rectangle. Remember? The more rectangle, the more you have better accuracy. Only 4 rectangle to estimate this. That's very like, it's like building Lego, right? You never have the curve, you have to have beautiful. You only have some brick, right? Just a bunch of brick. You never have a beautiful curve of anything you try to build, right? It's more like Lego right there, right? So technically, like that. Okay. So 2 little rectangles. That is the key. You need more rectangles. Okay. All right. Put that in simulator. Feed that to ChatGPT at around 1,000 or 1,000,000. You're gonna see right away. It's really close. Okay. 4 barely scratch the surface. Midpoint. One more time. This time, I will have you do the drawing. But you can practice, do the calculation at home, right? Okay. Same. -1, 2, 3. Okay. Midpoint. It will be a little bit different, right? Midpoint. You pick the middle. It goes up right there. Middle. I don't like it. And middle one more time. There. Midpoint. 4 rectangle. Okay. If you actually have to do the calculation, what will be delta x? Still 1. The width of the rectangle. But what will be the height of the first one? You're going to multiply, right? Delta x equal 1. Okay. Multiply the first one with f of?
-1 plus 0.8.
Not really. Okay. This is -1. What is this number?
0, 0.
Then what would be in the middle? Negative 0.5. Yeah, -1/2. Right, understand? Okay. 1 right here. The middle. 1.5. Is it? 3/2. 1/2. 1/2. 2/2. 5/2. Right? Okay. So that are those in the middle point. So -1/2. 1/2. Is it 3/4? 3/4? .75. No, you're tripping me, man. Right?
I don't think so.
1, 2. That is 1.5, right? That should be 1.5.
That's. Oh, okay. Never mind.
That is 1. That's 1. That is 2. Yes. No problem. But yeah. We need to argue. You need to argue to get the correct answer. Okay, don't sleep on the mistake.
Would have been a big mistake.
Okay, 3 over 2. And that would be 2, then it would be 5 over 2. Right, or 2.5 if you want to use decimal. Because even at the end of the day, you're still blocking those numbers. Okay, so 0.5, 1.5, and 2.5. So those are the numbers you're going to plug in. F up, F up, F up. Okay, and practice that. Blah, 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 blah. You will end up with 43. And actually this one is the closest one, the middle one. Remember the true value is 44. This one is 43. This one is the best approximation. This one the best one. Okay. Practice the calculation, huh? Okay. And there's also upper and lower. Any questions so far about this? So right now, what we have is just this. That interval between -1 to 3 of your function dx is around 43, around 58, around 34. Okay, none of them give you the equal. In order to have the equal, you put it inside the limit, you let the number interval run to infinity, then you have the equal. Okay, and doing all of that process, that tedious process, a lot of calculation in the middle, we have the privilege, we inherit just the formula. Okay, so now we do the formula. Evaluate the interval to compare with your estimate. Evaluate the interval, that means you are finding the true value, not just approximate anymore. Okay. Okay, so what does it mean by doing that? -1 to 3, f of x, 4 plus x, what was it, 3x squared, dx. Okay, 4x squared plus 3. All right. To do this, remember this is technically finding antiderivative. Finding antiderivative. Okay. Yesterday we practiced a bunch of antiderivative, remember? Recall yesterday. Recall a few things. I keep rewriting this example, remember? Okay. You have this. You take derivative, it gives you 1. Okay. And then antiderivative, that means go backward. Then what will be antiderivative of this one? 1 over
3x, 3 plus 2.
There you go. Okay, there you go. There you go. Okay, instead of writing like this, Okay, actually, okay. Informal, very informal. The formal way of writing all of this thing now is this. Still there. That is the calculus way of writing this. Okay, basically the same. Find antiderivative of that. Instead of saying find antiderivative, integrate this or evaluate the integral. Okay, because you plus it. Okay, plus it because it's a general. General. This also we have general antiderivative. We also have general integral. That is general integral. Okay, we can have a particular integral. So now, what does it mean by particular integral? I just put an actual boundary, an actual limit to that. So let's pick, give me 2 numbers. Give me 2 numbers. Just 2 numbers. Put that in the interval. 0 to? Too much. Smaller. 4 you're going to put in. Another one. Smaller. Help me. 1. Okay. There. Okay. So you're going to have exactly the same thing. You're going to have exactly the same thing. But instead of this plus C, instead of that plus C, now you just plug in these 2 numbers. How do you plug in? You write like this. 1, 0. Okay. And then you plug them in. 1 over 3, plug in 1 cube right there. 1 cube minus, very important, minus 0 cube, which is 1 over 3. That 1 over 3. Okay, so this is general integral. This is definite integral. Okay, the general interval, definite interval. Definite, you have a definite interval. Any question? Any question? Okay. Four would give me 4x. 3 is there, right? How about x squared? Mm-hmm. Okay. If this problem doesn't have this, then what would be your answer?
That plus c.
There, that would be my. There, that is the answer. That. And because we have that is general integral. Because we have the interval -1 to 3, then we do this. Yeah. Okay. All right. Then you plug in exactly like this. Plug in the first number wherever the x in, subtract the second number wherever the x in. Okay. Plug in. 4 times 3. Actually, this 3 cancels with this 3. Right. Plus 3 squared, 3 cubed. Subtract. Don't forget the parentheses. 4 times -1 plus -1 cubed. Okay. So I basically rewrite this one. Exactly 2 more times. At the same time, I plug in 3, plug in the top one, subtract that, plug in the bottom one. So 3. There, here, -1, here. Do the calculation. Okay. 12, 27 minus -4 minus 1. 39 minus 1 minus 5 plus 5, 44. There you go. That is the true value. Remember earlier I told you the true value is 44. And only with this direction, this calculation, you can use that equal sign. You can use the equal sign. When you use L, R, M for whatever the number, you can only use the approximation. Okay. So actually, they say compare, right? Compare. So which one will be your best approximation in this problem? The midpoint, right? Okay. For M4 is the best approximation. Therefore, it's 43. And somehow, this is it's not easy to understand this concept right here. If this, recall again, if this is your function of velocity, between -1 and 3. So it doesn't mean you walk on a line, on a straight line between -1 and 3, the velocity there. Then somehow that number 44 is the total distance that you just walk. Right? We did that yesterday. The kid didn't die, right? We did exactly that. We did exactly that without the formality of this thing. Okay, we did that. We integrate that. We take antiderivative that. We plug in some number, we get some number. And that number represents the total distance traveled. Then if this velocity, that will be the distance traveled. If this is the movement, if somehow you slow down, speed up, then somehow you're able to calculate the total distance, which is the area right here, those rectangles. Okay. But why? Okay, that's your job to find out in Calc 2. Okay, that's your job to find out. Eventually, you're going to learn. It takes a couple of years, to be honest. It takes a couple of years to get all of that concept, to sink all of them. A few classes, not just math, and then physics, and then all. It took me around 4 years, up until my really 5th years, to actually understand why is that. Okay, so it will come. Express that area using limit. Okay. So this means, how did I get that number, 44? Okay. Express this number, 44, from here to here. There is one equal sign somewhere in here that you bypass. Okay. You literally, we cheat by jumping the loop right here. Okay. Why do we get this become 4x? Not because I say so, right? Not because I say that yesterday, no. Okay? Not because we have formula. Because a lot of things, because of this summation. Mm, 4 plus 3x squared dx. It actually, before you have this, plus before that, a lot of things happen in the middle, and that thing, it is probably the most complicated expression you write on this class, in this class. We will do the math to show that thing somehow give you this. Okay, we will do that. We will do that. Okay, but that will be next section. Okay, that will be the next section. In the next section, we will actually evaluate E, which it is, that E, which give the same result as D, which it is, and then eventually give you 44. Okay. Okay. Next section. Okay. All right. Same like limit of the different quotient. Okay, give you the derivative. Okay. Find the expression of limit for the area. Okay, so that means when you was asked to find the limit of the expression using this, you just put that inside the limit. Put that inside here, right here. The only thing you got literally that problem, copy and paste this thing, and then replace that function with the new function. And that's it. Done. Okay. This same as yeah, right there. Same thing. Replace the function. Nothing else. Nothing new. Okay. Let's go to the next section. 5.2. 5.3. Okay, we're gonna do that over here. Okay. Everything must have a name. Everything must have a name. I'm gonna, because I don't want to go too much into detail for you guys. Okay, I think you understand that. And okay, all of that. Okay. Right here. I think you know that I'm gonna draw a curve with a bunch of rectangles. I'm not gonna do that again. Okay, we're just going to go straight to the result. But before that, we have to call out a name of this one. The integral is the limit and approach infinity summation f of xi delta x. All right. Okay. That thing, that summation right there, that whole thing, okay, that whole thing, the limit of the summation multiplied by the width. This is the name of that thing. Riemann. Riemann is a French mathematician. Riemann. The sum, right there. Okay, he called the names. So Riemann. Okay. Yes.
And the summation, does the I stand for like integer or something, or is it just like the letter that's used?
Oh, actually, and I stand for the. It's just a letter. First of all, it's just a letter. Okay, it's just a letter. It just tells you the location, the indication, where you start, where you stop. Okay, because later on in Calc 3, not Calc 2, in Calc 3 you're gonna have double summation. Summation of summation. And then you're gonna have, okay, the second summation, how I want to start at some number, but I cannot use the I again, I use J. I cannot I stop at the same point. And there. It could be different, it's just an alphabet. It could be A, B, C, it's just an indication. Okay. All right. Okay, so if F is interval between A and B, one more time, that is just the limit of n approach infinity what am I making you to do? I'm just making you to write that thing 3 times already. So you can at least memorize that. That 2 times, one more time just from previous section. Okay. Okay, where delta x, how did we find delta x yesterday? The width between A and B. Between A and B. Between A and B. Yesterday, let's say we have 4 interval, 4 rectangle between 0 and 1. Between 0 and 1, 4, 2, 3, 4. Then how big is each rectangle? 1/4, clearly. I change that number to 4, that is 1, right? Still 1, right? Still 1 there. Okay. I have to practice, give better example. 18. Now I'm going to randomize. 6. Okay. How big is one each example? Everybody can see that? 3. Right? 9, 12, 15, and 18. So 3. How did you get that 3? The point is that earlier, the 1/4, the number 1. How did you do that?
18 minus 6 divided by 4.
The last one, the last number, minus the first number. 4 is the number of the number of rectangle. Right. last minus first divided by the number of rectangle or intervals. Okay, so b minus. So if you have n, right, blah 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 blah, n of them. So you have b minus a over n, which is the width each rectangle. Okay, xi. Xi, we haven't talked about this. That means where is each position, each x? Okay, the first one is right there, x1. Second one, x2. Third one, x3. x4, blah, 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 blah. Last one, xn. How do I pinpoint exactly the location of each x? Let's say somewhere in the middle, in that dot, 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 dot. X 100. How do I know how big is that x? For example, right here. That is 3. That is 6, 9, right, and so on, right? Then how big is this? Okay, again. How much? How did you get 3? How did you get 6?
Subtract.
You subtract what to what? How did you get 6? 12 minus 6. 15 minus 6. How big is this?
X1 minus A.
X1 minus A.
X2 minus
That's how. Okay. This is x1 minus A. That is x2 minus A, and so forth. Right. Then what would be xi? What would be xi?
xn minus A.
Hmm?
xn minus A.
Xn minus A. There you go. Okay. We need those two to actually calculate the limit. Before I move on, before I start with this problem, any question? Any question? Okay. This is also going to be the most difficult, and actually the last one. The last one in terms of difficulty is this expression right here. We're going to do. Okay. So I want everybody on board before we do that. Okay. Okay, let's go. I skip that. I come back to this. Somewhere along the line, when we do that summation, we're going to have a little bit of properties. Okay, we're going to have some I, Q. These terms going to pop up. Okay, rho and T. When you do that calculation, those terms going to pop up. Then you need some formula for them. Okay, and yes, I will give you these formula. Okay, starting with the C first. Okay, starting with C. This is the easiest one. Summation of C starting with 1, stop at n. What do you think? Summation, that means you add up C starting when you have first one, C, another C, and C, right? When I equal 1, that's the first one, second one, third one, nth one, and all of them n times. Okay. Next one. Okay, actually I will make sure I'm on the right track here. Okay. I, starting with 1, plus 2, plus 3, plus 4, on the way to plus n. What do you think? What do you think about this? I'm missing 1 plus 2 plus 3 plus 4 plus on the way to n. I think you probably saw this problem somewhere. There used to be a problems. 1 plus 2 plus 3 plus on the way to 100. There was that kind of problem. Remember that one? And there was a trick to do this problem. Okay. I'm going to write more terms. Okay. Right? Between them. That is another 100, right? Another 100, right? And so on. Right. A tail in the top. Okay. It's called tail top problems. Okay. Same idea over there. But you stop at n. N plus 1 divided by 2. Okay. This is one of very old problems. Okay. Back a couple centuries, not just decade, couple centuries. Okay. Actually, it's over here, my bad. N plus 1 over 2. Okay. I swear, and IQ, they are too much to prove, so I just give you the formula. N plus 1 to n plus 1 divided by 6. Okay. N plus 1 divided by 2. The whole thing square. It's based, okay, somehow this one, the cube one, is actually the first one square. Okay. In Taylor series, you're going to learn this. Okay. In Taylor series, you understand why is this. Okay. This is also another property, not a really formula, a property. If you have a constant, you can throw that constant outside of the summation. Okay. So we're going to use one of each. Okay. Maybe 1 time, 2 times for each one of this. Okay. Now, let's do it. This one. Given the integral x cubed minus 7x, approximating the integral using R4. Later, we're going to root. You're going to do this one. Okay. Same like last example, right? Same like last example. R4 for rectangle. Draw them. Okay. We're going to do this. Express the integral as limit and summation and evaluate that limit. Okay. So express it first. The integral from 0 to 4, x cubed minus 7x dx. As limit summation. Okay. I will start with the formula first. Okay, I'm going to go really slow with this problem. Okay, as slow as possible. I'm going to take solid 30 minutes just to do this problem. Okay. Next, what is my function? The only thing I'm going to replace in from here to here is right there, f of xi. I'm going to replace this f of xi with this function. That is my function. Okay. See that? That is a wrong. No, that is incomplete replacement. Okay. You're not going to erase anything. You're not going to erase anything. You need to add something when you do that replacement. You need to add something. Okay, this is f of x, right? Everybody agree? F of x. I need to plug in f of xi. F of xi. This is f of x. Where's the letter I? Each one of them has to have the letter I. Okay. I. That letter I. Okay. Okay. In here, delta x, we need to plug in two things. We need xi and delta x. Actually, delta x first. Xi. Okay. Delta x, we also did the calculation, right? The last one minus the first one divided by the number of interval. The last one is 4 minus 0 divided by n, that is 4 over n. Okay, the number of interval, okay, 4 over n. Now xi will be a plus delta x. I delta x, my bad. I delta x. A 0, plug in. Delta x, 4 over n. So basically you have 4i over n. Okay. Plug both of them in. Here, here, and here. Okay. Any questions so far?
Where'd you get the A from next to the X one?
Oh, that's how we derive xi. Xi so let's say pick xi somewhere in here. X1, X2, maybe, okay, X3, X4. Each one of these is a delta x. 2 delta x, 3 delta x, 4 delta x, right? And the first one is A. So x4 is A plus 4 delta x. Right. The location of x4. In the first one plus 1, 2, 3, 4. 4 of them. Okay. Similarly, x5 will not be another 5 delta x. 6 will be 6 delta x. So xi will be A plus I delta x. really debating whether I want you to do this problem or not. Because if I don't, because every semester I do this, and because this is the first time we have this calculus in summer. Cal 2 is different. Cal 2 they learn everything. Cal 2 is a two-month class. All right. Because if I don't, I have to pick either this or the trig substitution. There's another one. There's another one on par with this one in terms of difficulty. Okay. This one is more difficult than the other one, a little bit. I have to pick either one of them to show up on your exam. Okay, that's the rule. That is the back door behind the door, behind the closed door rules. Okay, so either one of them have to show up on your exam. Okay, they need to know them. This or trig substitution. Do you like this one? Do you want me to finish this one? Or you want to have the other one, but the other one you haven't seen that. So it's not really fair to ask you that too. Because doing this. And yes, if they show up, it's going to be root work, this one. Should I keep going? You know what? Scratch it. Scratch it. I skip you on the hassle. Okay? I skip you on the hassle. I will, in fact, I may put this as an extra credit problems. Okay. At the same time, I will put up the solution to this one. Okay. I will put a solution to this one. I may give you an extra credit on the exam, this problem. You can try it at your own risk. Okay. And if I pop it up, 10 points. 10% of your final. Okay. Try that. Okay. Read that, but I don't want you to, okay, for the average of class, I will skip this. Okay. And I give you the answer right away, which is, where is that? Actually, I walk you through because we have the solution for that, right? I walk you through. They just learned that just last semester. Where is that? 5.2. Yes, we were old school in 5.2. Just this problem. You're supposed to do this. Yep, we were supposed to do that. See why I say I keep scared for you. We were supposed to do that. All of that. And they have to do that in the final exam. Either this one or the strict sub. And they pick this one. Okay. Actually, I'm going to walk you through that. This is where we were. Add delta x. 4 over n, plug in. There you go. That's where we were. Okay. That's where we are right now. Okay. I'm just going to walk you through. Okay. Okay. I may post this note. If you want to learn that, for free. Okay. You need to know this too. This technique, because in Cal 2, remember the Cal 3, the summation of summation, it's going to show up. Okay, this is where we are. What? We plug in. You have delta x, you have delta x. Where is that? For I over n. There you go. Delta x. And 4 over n, delta x right there. Xi right here. Plug in. What next? Just purely algebra. Whatever comes next, just purely algebra. Cube. 4 cube, 64. So cube everything. I cube, n cube. Okay. See that arrow? Distribute. 4n come in there. There, distribute. 7 times 4? There. Okay, so understand? Just distribute and cube and square. Another algebra. 64 times 4? 256, right there. Okay. 28 times 4? 120, 112, right there. Okay. And also at the same time, rearrange a little bit. I cube still there. N cube, n, and 4. N square. And the I. Okay. Good? This step good? Algebra. Next. In here is the summation. Okay, this is where it's tricky. The summation, starting with I, stop at n. In other words, it's like you take the derivative with respect to x, then everything else is a constant, right? You take the derivative of 3x, that number 3, you usually throw it outside, right? Because it's a constant. The derivative, 3x, 3 go outside. You only take the derivative of the x. So anything that is constant, you throw it outside. We used it properly. If you have a constant, anything with the I, you keep inside with respect to the I term. So the I stay inside. Constant, go outside. So in this problem, anything with the I stay. Anything that not include the I, treat it like a constant. So I highlight that. So it's 256 over n4. Okay, that is a constant. This is also a constant. What do I do with those constants? I put it outside, see? Okay. Put it outside. Go outside, there. Go outside, there. Now it's probably IQ and I. Earlier I gave you a few formulas, right? The IQ give you this. The I give you that. The purple and the red one, they are formula. Okay, you need to understand a lot in there. Just formula. Nice. There you go. Okay. So far good? Okay. Next, back to the algebra. Back to the algebra. 256 divided by 4. Simplify. 64. N squared over there. N4 over here. Cancel. I have n squared out there. Right. Okay. That term and this term give me this. 256 and 4 give me 64 right there. Then if I cancel all of that, I only have this, right? Right there. Okay. One more time for this. So the number just cancel. 112 divided by 2 is 56. There. N and n squared. So 2n down there, 1n up here. Cancel one of each, 1 down there. N plus 1 still there. Okay. And because you already have used the line as summation, so when after this step, look at this step. Find the summation. No more. That's the property. Use the summation formula, you get this. So right here, you go back. Okay, after simplifying, what do you see? This line, what do you see? What do you see on this line? What kind of problem is this? It's just a limit problem with n. No more summation. So you usually have a limit of summation. Now summation is gone. Now limit only. Okay, what kind of limit problem are we looking at? Limit go to infinity. Okay, you see this? These two. I just group them. I combine them. I group them into this. Both of them are square. See that? So I can group them into one fraction that have the big square outside. N minus 1 over n. This square outside. Okay, see that? 64 still there. One more time over here. Group them. Just bigger parentheses. That's it. Okay. What do we do with this? If I don't look at down here. Don't look at down here. What do we do with this? If n goes to infinity, we divide by the highest degree of the denominator. Remember that? I divide there right here. There you go. I divide. So divide anything over n is 0. 1 over n, that is 0. This is n over n, that is 1. That is 1. 1 minus 0, n over n also 1. So in other words, you cancel a bunch of them. That leaves you with 64 minus 56. Constant. Limit of constant is a constant, that is 8. And all of that can be done using the formula. Remember that equal sign is right here. Okay, that equal sign is right here. You just apply, okay, right here. Actually, from here to here. How do you get from here to here? How do you get from to 8? All of that limit. What happened? You see x cubed. Antiderivative of x cubed. 1 over 4, right? 3 plus 1. X to power. Right there. 1 over 4. X to power 4. Negative 7. X squared over 2. Right? There you go. Antiderivative. Remember? Plug in 4, plug in 0. That's what I did. Okay. So you inherit the formula. This is what I expect you to do. I will skip that. But I want you to understand that. What happened right here? That equal sign. It's not that simple. That equal sign is all of this. That 2 pages long. No, nearly 3 pages long. That equal sign is right there. Okay. Welcome to calculus. Right. Welcome to calculus. And that is supposed to be the calculus, the nature of calculus there. If you go back to 1990, no, not 1990. No. 2001. Steelwork Calculus book, 2001. Calculus 1, stuck right here. The limit, the derivative was pre-calc. Back in the day, they don't have calc 3. Back in my time, no, a little bit before my time. We only have calc 1 and calc 2. Calc 1 stuck at chapter 5. Literally 1.1 in calculus. You learn integral. You learn finding area under curve. The derivative, the limit, nearly 20 years ago, that was pre-calculus. I don't know what happened to education. I don't know what happened, to be honest. Literally, okay, that was pre-calc. This used to be 5.1. Okay, and usually that whenever I teach this section, I always actually say that welcome to calculus. It actually truly mean that you start studying calculus by studying integral. Before that, pre-calc. Okay, the limit was pre-calc. And eventually it keep moving the stuff from pre-calc to calc. And now we have calc 3. I don't know why we have calc 3, but now we have calc 3. Okay, I didn't have calc 3 back in the day. I only have calc 2. And that's basically the calculus sequence, 1 and 2. Now we have calc 3. All right, so you see. So if you see it's difficult, it should be. It's the nature of this. It should be. Okay. And because we're summer, I cut you some slack, skipping that. But I shouldn't. Okay, keep that between us, okay? Get out. Don't snitch me, okay? Where was I? Okay. Try that at home. Try that at home. Maybe you see that in the exam. Okay. Okay. So now, let's take 10 minutes break. Come back. We're gonna practice. Enough theory. Okay, enough theory. We're gonna come back with practice. Okay. I have something big to tell you when you come back. Okay. So take 10. Come back at 11:10.
called me while I was like, no. No. My classmate, my peer. I'm done. Oh, is that why? Is that why she called me?
How loud?
Yeah. She called me right when I said I'm done. I'm not picking up. Yeah. Yeah. I know it fast. Who? Right. I don't know. I'll send it to her.